In order to become increasingly independent of fossil resources, plastic-based products could be substituted partly with biomass. One such technology is wood plastic composites, a combination of petroplastics and wood fibers. Their development into products is complex and requires a holistic approach. This is why the Compolytic principle has become established in recent research on bio-based plastics. It combines polymer science with socio-technological studies for the optimal development of wood plastic composite products. Latest studies can make a further contribution to the state of research, and Compolytics now presents its newest peer review paper under the following title: Thermoforming of Wood Plastic Composites. A Compolytics approach translating combined polymer and policy analyses into industrial design principles. This study derives an explanatory model for thermal forming of wood plastic composites from 7 publications by the author. Results are combined with findings from a previous consumer and expert survey on wood plastic composite facades. Universal design principles for such facades are then derived. A mock-up sampling tests these in practical application. Get more information about the paper content from the abstract now. Wood plastic composite saves plastics, but products are still limited to linear decking and cladding. For advanced productions of 3-dimensional wood plastic composite, design principles were derived from 7 published pre-studies on thermoforming. For this, a combined method of polymer research and socio-technological investigations, reported in WPC Research as Compolytics approach, derived a total effect model for thermoforming and developed a decision tree with target group-specific settings of production parameters. 14 application-relevant material properties were influenced by thermoforming, with strongest effects on color, followed by strength criteria. Satisfying private deciders' preferences for optimal facade appearance, a highest possible temperature should be applied for narrow bending under high wood content. Professionals value maximal strength, which demands a compound-independent wider bending at lower heat. The applicability of the design principles were assessed by case studies serving further research on wood plastic composite product development. This article is published in the Springer's International Journal of Advanced Manufacturing Technology, Volume 123, issued January 2023, and the author is Professor Dr. Daniel Friedrich.